Okay, so in the book, it has these notes on the discriminant. It tells you the value of the discriminant. Right here, it's saying if your discriminant is positive, right, because it's greater than 0. Okay, so if you have a value that's greater than 0, it must be positive. Even if it's a decimal, it's positive, it's greater than 0. Now, what does that mean? That you're going to end up with 2 real answers, 2 real roots, 2 real x-intercepts, 2 solutions, whatever you want to call it. Answers, solutions, roots, x-intercepts are all the same thing. Now, what does that mean visually? That means that your parabola will cross at 2 locations. Okay? What if your discriminant value inside the square root of the quadratic formula, what if it's positive? Wait, we already said that. What if your discriminant value is equal to 0? Well, then that means you're only going to have 1 real answer, 1 real root, 1 real x-intercept. What does that look like visually? It's a parabola that just touches the x-axis. Or maybe it's a parabola opening up that just touches the x-axis. But if your discriminant is 0, you're only going to get 1 answer. Because if you add or subtract 0, it's not going to change your value. And the last case, if your discriminant is less than 1, that means it's negative. And we all know that when you have like 2 plus or minus the square root of negative 4 over 2, we know that this is going to produce an imaginary number. So if you're looking for the answers, you know you're not going to get real answers, which means you're not going to get real x-intercepts, which means that you're not going to get real roots. You're going to get complex roots, which are imaginary, which means that you're not going to cross the x-axis at all. So when your discriminant is negative, your parabola will not touch the x-axis. This is very important for the next section and for the final exam because we really need to get good at graphing parabolas and understanding where they cross the x-axis, the x-intercept values. So again, if your discriminant is negative, your parabola will not touch the x-axis. It will not have real answers. It'll have complex answers, complex roots. To the next one. So this is kind of like a summary of solving quadratic equations. This is also in the book. Now, if they give you a quadratic equation, if you were to graph it with the graphing calculator and you look at the x-intercepts of your parabola, that will give you the answers, right? Because x-intercepts are answers. Now, will you always find answers by graphing? No, because the parabola sometimes doesn't cross the x-axis. So, can graphing be used to solve the method? Could you solve by graphing to find the answers? It says sometimes. Because if you don't have real x-intercepts, you're not going to be able to find your imaginary answers. Okay? How about factoring? Well, we learned in the past quiz or so that not all quadratic trinomials are factorable. So sometimes it works, right? Sometimes you could actually factor, split, and solve. Kind of like if you have x squared minus 1x minus 6 equals 0. Hey, you could solve that really easily. You go x equals 0, and that'll be a negative 3 and a positive 2, which means that your 2 answers will be a 3 and a negative 2. So those are your 2 answers right there. But the thing is, factoring, splitting, and solving doesn't always work. What if you instead of a 6, you had a 7 right there? Then you couldn't factor it, so factoring doesn't always work. So factoring, it only works sometimes. Graphing only works sometimes. Square root property. What does that mean, square root property? Well, if you have like x squared equals 9, yeah, you could square root, and you'll get the answers x equals plus or minus 3. That works sometimes, right? Completing the square always works. Completing the square always works. However, if our b value is odd, it's really long and challenging to complete the square. But the latest thing that we learned, quadratic formula, that's our winner right there. Winner, winner, chicken dinner. That always works no matter what. And if you're good at simplifying, you'll be good at solving anything with the quadratic formula. Now, jumping to today's actual assignment, dealing with the discriminant, I kind of want you to not really follow the instructions that much. It says find the value of the discriminant. Let's do that for sure. So, number 11, let's find the value of the discriminant. Now, we know that we have the quadratic formula. So if they were asking us to solve it, yeah, we would plug in the a value of 1, the a value of 2, the b value of -6, and the c value of 9 in the quadratic formula, and we simplify it completely, and we get our answers, and those are our solutions, our x-intercepts, our roots. However, they're not asking us to do that. They're asking us to find the value of the discriminant. So let's just do the red part, the b squared minus 4 times a times c. So the b part is -6, correct? And the 4 times a, that's going to be times 2, and the c value is 9, okay? Again, the b value is -6, the a value is 2, the c value is 9. And when we work out this discriminant value, which would really, this answer is really belonging inside the square root if we were to do the whole thing. But right now they just want us to find the discriminant value. So I really end up with 36, and I have 4 times 2 times 9. 4 times 2 is 8, 8 times 9 is 72, and there's only one minus sign, so that's a -72 or a -72. So what is 36 take away 72? -36, correct? Yay? This is our discriminant value. Now what does that mean? That means that if they asked me to solve, this would be my value inside my square root, correct? Yes or no? Okay, now, because we know that the discriminant is negative, then this number inside here is -36. What's going to happen when I keep working this out with the -36? I end up with a plus or minus 6i, correct? So our discriminant value is negative. That means that I'm going to get imaginary answers. So the other part of this part B, it says describe the number and type of roots. We would say because it's negative, what could we say? Because it's negative what? No real answers. No real x-intercepts. So we want to write this out, guys, okay? Because it's negative, you don't get real answers, you don't get real x-intercepts. You could even write down other thoughts. Your parabola does not cross the x-axis. You end up with imaginary answers or complex answers, right? So you could write down all this explanation, this explanation right here, you could write it down and more for number 11 and 13. Let's jump to another one. So over here we have the same situation where they're asking us to find the value of the discriminant, and then after that describe the number and the type of roots. So again, roots are just answers. So what we're going to say, again, if it's positive, if our discriminant's positive, you could say there's 2 real roots, there's 2 real answers, there's 2 real x-intercepts. The parabola will cross twice if the discriminant is positive. If the discriminant is equal to 0, what do we say? If the discriminant is equal to 0, what do we say? You get one answer, you get one x-intercept, you get one solution, you get one real root, right? If the discriminant is negative, you would describe, you get no solution, no real answer, no real roots, no real x-intercepts. The parabola doesn't cross the x-axis. That's the description that we want, or the explanation that we want on each of these. You guys want to pick one? Anybody? 31? 31. So, what's my A value? My B value? My C value? No. What? The C value is not -4. Ladies and gentlemen, you know when the quadratic formula works? When it's set equal to 0. So the very first thing to do is to add 9 and add 9. And now you could really rewrite your nice standard form equation. And now we could see that the C value is really 5. Yay? Now inside the quadratic formula, inside the radical, inside the root, we have our discriminant, which is b squared minus 4 times a times c. That's inside the root of the quadratic formula, negative b over 2 times a. But you know what? I only care about the discriminant right now on this section. So let's go with the b value, which is b value is 2. The a value is 1. And the c value is 5. So the a value is 1 and the c value is 5. So when I work this out, my discriminant value will be 4 minus 20, which ends up being negative 16 inside the square root. So my discriminant value is negative 16. The discriminant is negative 16. So we know the discriminant. We found the discriminant. You would write d is negative 16. What else could we say based on that discriminant being negative 16? There are no real answers. There are no real roots. There are no real x-intercepts. If you were to graph the parabola, it will not cross the x-axis because the discriminant is negative, because that'll cause it to be imaginary answers. I hope this helps, guys.